Namaste students, welcome back to my channel. This question is from JEE Mains 2026, 21st Jan morning shift. And this question is from Eudiometry concept, one of the very crazy question. You should be like a analytical thinker. Okay, I'll be just explaining you this question in a very slow manner, and it is different from other YouTube explanation video with the same question. Okay, now the question says very simple: 80 ml of hydrocarbon on mixing with 264 ml of oxygen in a closed U-tube undergoes complete combustion. The residue gases after cooling to 273 Kelvin occupy 224 ml. Okay, when the system is treated with C₂H solution, the volume decreases to 64 ml. The formula of the hydrocarbon is, yes, so hydrocarbon undergo combustion process, that is oxygen. So before we understand the question properly here, so let me write the general equation between any hydrocarbon and oxygen. The general equation is C₄H₆ plus X plus Y by 4 O2 will give rise X CO2 plus Y by 2 H2O. Okay, so here how many moles are there? Here 1 mole is there. And what about here? Here will be X plus Y by 4 mole of oxygen, and here X moles of carbon dioxide, and this one will be the Y by 2 moles of water. Now let us come back to the question here. 80 ml of hydrocarbon on mixing with 264 ml of oxygen. So that means hydrocarbon is this C₄H₆. So 80 ml. Okay, it is mixed with 264 ml of oxygen. According to data, I am writing it. Okay, in a closed U-tube undergoes complete combustion. The residual gases, they are saying here, that means this oxygen is a gas, carbon dioxide is a gas, and H2O is a liquid. So let us neglect this one. That means when 80 ml of hydrocarbon combines with, so 80 ml of hydrocarbon combines with 264 ml of oxygen, it gives rise to formation of how many moles of CO2? We will determine this one. Very easy manner. So the residual gases after cooling, this is important. The residual gases after cooling to 273 Kelvin occupy 224 ml. Remember, residual gases. I'll write the data here. Residual gases. So how many ml here? That is 224 ml. So that is 224 ml. This contains oxygen gas also. Then this contains carbon dioxide gas also. So oxygen is also a gas. Carbon dioxide is also a gas. Okay, now how much carbon dioxide is there, how much oxygen is there, we need to check it. Again, further we'll continue with the question. When a system is treated with C₂H solution, the volume decreases to 64 ml. Okay, what happens here means, if you use C₂H, this C₂H will absorb only carbon dioxide. Okay, it will take only the carbon dioxide. So according to statement, after adding C₂H, this 224 ml is going to convert into 64 ml. Then what is the difference 224 and 64, what is the difference? Will be 160. What happened to 160 ml? This 160 ml is nothing but it is a carbon dioxide. Sir, why sir it is a carbon dioxide? Means because I told you KOH will absorb the carbon dioxide. So what will happen here if you introduce the KOH? No, it will take all carbon dioxide. The left out part is oxygen. That left out part oxygen is 64 ml. From the following data, it is very clear that volume of carbon dioxide is 160 ml. So volume of oxygen will be how much? 64 ml. Now that means left out. How much ml is left out now? 64 ml is left. Okay. Now we'll just check the formula of the hydrocarbon. From this data, we are going to solve it. So how to solve? Very simple. Now we got how much carbon dioxide has been produced. So how much carbon dioxide is produced here? 160 ml. Now let us compare 1 mole and x mole of CO2, 80 ml and 160 ml. We will find the value of x. If you find the value of x means we will find the value of number of carbon atoms. So let me do it. So 1 mole of hydrocarbon gives x moles of carbon dioxide. So 1 mole of hydrocarbon will give x moles of carbon dioxide. So now we got it now. 80 ml hydrocarbon will give 160 ml of carbon dioxide. So 80 ml of hydrocarbon gives 160 ml of carbon dioxide. Now what will happen here? X is equals to, let me do the calculation here only. X is equals to 1 into 160 divided by 80. That means x value will be 2. So x value will be 2. That means x value is 2 means it should be C₂. It should be C₂. So option 1 is having C₂. Fine. Option 2 is also having C₂. Fine. Option 3, no. This is not the answer. So option 4 is also having C₂. That means we need to find. So we got x value is 2. Now we need to find what is y value. Y value may be a 2 or 6 or 4. So how to find the y value? Already we are aware that x value. We need to find what is the y value. So what I will do now here means I will relate this combination. So 1 mole it combines with x plus y by 4 mole. So let me do it. 1 mole of hydrocarbon going to combine with x plus y by 4 mole of oxygen. Already we are aware that x value is 2. Substitute the x value 2 here. So let me substitute here 2. That's it. Now very simple. 64 is left. That means we had 264 ml. Only 64 is left means then how many ml has consumed? 200 ml of oxygen has been consumed. So from this it is very clear that 80 ml combines with 200 ml of oxygen. Let me write it. So 80 ml of hydrocarbon combines or combined with 200 ml of oxygen. So now what happened here? Calculation. 2 plus y by 4 is equals to 1 into 200 divided by 80. If you do the calculation, so y value you will be getting 2. Please do the calculation. So here 0 will get cancelled out. So 20 by 8, it is nothing but 2.5. So now what will happen here? 2 plus, okay, let me write it full. 2 plus y by 4 is equals to 2.5. So y by 4 is equals to 2.5 minus 2. So y by 4 will be the 0.5 and y value will be 2. That's it. So we got the y value. So this is how the calculation goes. This is very little lengthy one here. So y value will be 2. So where is the y value will be 2? So option 4 is not the answer. Option 2 is not the answer. Then the correct answer is option 1. So this is one of the best method. It takes time, but you will understand the concept where Eudiometry concept is greatly involved. Okay, and limiting reagent is also there. So I hope you understood. Thank you so much, my dear students.